So we need to give you another equation that you can use to solve problems. And so here it may be a situation where you know the hydroxide concentration of the solution and you're trying to figure out the hydronium. So if you're trying to figure out hydronium, so here's the molar concentration of hydronium, it's going to be equal to 1 times 10 to the negative 14 divided by hydroxide. So this is one you definitely need to know. Okay, so let's use this to solve a problem. So if I can increase the slide. So the problem reads as follows. If the concentration of hydroxide of a solution is 1 times 10 to the negative 5 molar, what is the concentration of hydronium? Is this solution acidic or basic? And then why is it when the hydronium is high, the hydroxide is low? So if I can decrease the slide. So here we are given a hydroxide concentration. We're trying to figure out hydronium. So essentially, really quickly, you just plug it into the formula like this. 1 times 10 to the negative 14 over, and then here the hydroxide is 1 times 10 to the negative 5. And so if you do the math here, what you should get is 1 times 10 to the negative 9, and then the units will be molar. Okay, so what I'm going to do is I'm going to erase this and write this over here. 1 times 10 to the negative 9 here, like this. 1 times 10 to the negative 9. We can put in units if we want. Should be a molar concentration. Hydroxide was given to us, so I'm going to write this here, which is 1 times 10 to the negative 5 molar. Okay, so now we have to figure out whether this solution is acidic or basic. And again, what you want to do is focus in on the hydronium concentration. If it looks like the hydronium concentration is greater than 1 times 10 to the negative 7 molar, that is an acidic solution. If it looks like it's less than 1 times 10 to the negative 7, then it's a basic solution. So 1 times 10 to the negative 9 is less than 1 times 10 to the negative 7. So this is definitely a basic solution. Okay, so the final question is, why is it when the hydronium is high, the hydroxide is low? So let me write out equilibrium really quickly. So you know at this point that in neutral water, before we add anything, the hydronium will be 1 times 10 to the negative 7 molar, and the hydroxide will be 1 times 10 to the negative 7 molar. So here what the chemist did is he or she increased the hydroxide concentration. They added enough hydroxide so that it was at 1 times 10 to the negative 7. They increased it 1 times 10 to the negative 5. So how does the equilibrium respond? So the stress is increasing the hydroxide concentration. The equilibrium will respond to relieve that stress, and so it's going to want to respond to take hydroxide away. The way you take hydroxide away is by increasing, again, this reverse reaction here. But think about what happens when you increase this reverse reaction. You were at 1 times 10 to the negative 7 molar hydronium. This will fall. And in fact, we know exactly how far it will fall. It will fall to 1 times 10 to the negative 9 molar. Okay, so if I could increase the slide. Okay, so this problem is a little bit more difficult. It says, what is the hydronium hydroxide concentration when enough sodium hydroxide is added to pure water such that the final concentration of sodium hydroxide added is 0.025 molar? Is the solution acidic or basic? So if I can decrease the slide. Okay, so here is the story here. We have sodium hydroxide, and we have it in a beaker of water, and its concentration is 0.25 molar. And so what we have to do is imagine here, here's our beaker of water, we're throwing this into the water here. What will be the final hydronium hydroxide concentration here? So somehow we're going to have to take 0.025 molar of sodium hydroxide, and then what we're going to have to do is figure out the hydronium concentration and then figure out the hydroxide concentration. Okay, so this is what you do. So you know when this water is all by itself, you have added nothing into it, it starts out at 1 times 10 to the negative 7 hydronium. and 1 times 10 to the negative 7 hydroxide. But here we're adding a lot of sodium hydroxide. We're adding 0.025 molar. So let's think about what happens here. So I'm going to move these just for a second. So here we are. Again, we're throwing sodium hydroxide in here. So here we have a sodium hydroxide, and the concentration is 0.025 molar. And what we have to do is imagine when the sodium hydroxide hits the water what it does. And so this is a strong base. It will totally dissolve in the water, and it will dissociate into ions. And so let's think about what we get here. We get sodium ions. I'll leave out the state symbols, and we get hydroxide ions. Now let's think about how many of these ions we get. Well, all of the 0.025 molar of sodium hydroxide will be converted to ions. And you can see that for every 1 mole of sodium hydroxide that you dissolve in water, you get 1 mole of sodium ion and 1 mole of hydroxide ion. So if you get 0.025 moles of sodium hydroxide, you will get 0.025 molar sodium and 0.025 molar hydroxide. Okay, so bingo, we now know what the concentration of hydroxide is in here. It was 1 times 10 to the negative 7 to start with, but when we threw in this large amount of sodium hydroxide, that increased to this value. So this is the value of hydroxide. So we know the concentration of hydroxide. Yay! So it's 0.025 molar. So can you figure out the concentration of hydronium? And so you may recall that the hydronium is going to be equal to 1 times 10 to the negative 14 divided by the hydroxide. And so it's going to be 1 times 10 to the negative 14 divided by 0.025. I'll leave out the units to make my life easier. And so when you do that math, you divide those two numbers. What I got when I did this, 4 times 10 to the negative 13 molar. All right. So we now know what the hydronium concentration is. And so now we can answer the final question. Is this solution an acidic solution or a basic solution? Again, we look at the hydronium concentration. We see that this is a number that's far less than 1 times 10 to the negative 7. So this is a basic solution. All right. So we'll go to the next problem. If I can increase the slide. Next problem reads as follows. What is the hydronium hydroxide concentration when enough HCl is added to pure water such that the final concentration of HCl added is 3.3 times 10 to the negative 5 molar? Is the solution acidic or basic? Okay, if I can decrease the slide. So here it's kind of similar in that you imagine here you start out with a beaker of neutral water where the hydronium hydroxide are above 1 times 10 to the negative 7. But unlike the previous problem where we added sodium hydroxide, here we're adding hydrochloric acid. And they give you the amount of hydrochloric acid you're adding. And so you're adding 3.3 times 10 to the negative 5 molar. So what you have to do is figure out the hydronium concentration and the hydroxide concentration. So let me work through how you do that. So the neat thing about hydrochloric acid, it's a strong acid. So when hydrochloric acid is put into water, it will completely ionize to produce hydronium and chloride ion. So if you start out with 3.3 times 10 to the negative 5 molar of that, note that this equation predicts that for every 1 mole of HCl that reacts with 1 mole of water, you get 1 mole of hydronium and 1 mole of chloride. If you throw in 3.3 times 10 to the negative 5 molar hydrochloric acid, that will all react with the same amount of water and produce the same amount of hydronium. So the hydronium here is 3.3 times 10 to the negative 5 molar. So we now know the hydronium here is 3.3 times 10 to the negative 5 molar. So how do you figure out the hydroxide? Well, that isn't so bad. Hydroxide is going to be equal to 1 times 10 to the negative 14 over the concentration of hydronium. And so it'll be 1 times 10 to the negative 14 over a concentration of hydronium, 3.3 times 10 to the negative 5. I'll just leave out the units like the book does. And so when you do that math there, I got 3.0 times 10 to the negative 10 molar for hydroxide. So is this solution acidic or basic? And again, you look at the hydronium concentration. If this number is greater than 1 times 10 to the negative 7, it's acidic. This number is greater than 1 times 10 to the negative 7, so it's acidic. So this is acidic. So thank you for listening, and we'll see you next time.